Hello everyone. Today I would like to report on one of the more recent project of mine, where what I'm trying to do is to have the PC being a supervisor controller of two robots. Each robot has their own RPi and their own CM-550. And in this video, I'm only showing the Python solution, and I'm using Visual Studio Code for the first time. The topics are, so we have a COMMANDO and a QUADRUPED for robots. Each of them have their own CM-550 and also an RPi acting as a local controller there. PC will act as a supervisor controller and using Bluetooth from the PC to the two robot. And I'm just going to highlight a few highlights of the Python solution that I use and show you what it looks like in Visual Studio Code also. So this is the COMMANDO. You can see the CM-550 here and the RPi 4B sitting on top. It has 4 GB RAM and run on 64-bit Raspbian. Both of them share into the same LiPo battery from the CM-550. So I had to have a 12 volt to 5 volt module to convert the 12 volt to 5 volt so that the RPi can use. The RPi also using TTYSO port, it communicates back into the CM-550 using 3-wire cable. The Pi-4B also using a PiCam on a Plantier platform. So the PiCam is designed to track certain blobs. So if there is a valid tracking, it's used whenever the CM-550 is set into the visual search and ranging mode. So, and the code that is running on the CM-550 is standard task code, you can see here. On the QUADRUPED, because it's smaller and there's not much room to put lots of things, so you can see that I here use the same LiPo battery, but I have to strip out the outside nice blue black box and just do a lock tape together, just bare minimum. This one have this Pi have 8 GB of RAM and 64-bit Raspbian also. PiCam is this time there's no room, so it attached to the body of the robot. Still 3-wire cable connecting TTYSO to UART, same scheme. So this one here, even though it can draw out valid tracking data all the time, it's run by the Pi, but the CM-550 only use those valid value only when it's not in motion. So that's the additional, because camera is being here, and as you know, it's the QUADRUPED is walking, so the image is going to be jiggly all the time. Okay. Next thing is, how do we set up Bluetooth communication between the PC and the various RPi? And I look a lot, and this resource here, this website, is probably the best. Succinct information, and it works here. So essentially, the Pi will become a Bluetooth server, and it watch signal coming out from its IF COM0 port, and then that means you have to pair it with the PC as usual. Like for example, this one, when it pair, it show up as COM9 on the PC. And when you check the Bluetooth property for this device, you can see that the RPi is designed to do lots of services, but the only thing we're going to look for and use is this serial COM port. Another thing too, that when we using Bluetooth BT21014, we don't have to worry about much of things. Here on the RPi, you need to set up the service. Basically, you turn on the service or IFCOM and watch it on channel 1 through this port. And so when they connect together, and then you see the message, press Control C to hang up. So this is the thing we're looking for all the time. So recuperation in the PC here, so it will monitor COM4 for the PTC and managing COM9 for the QUADRUPED. So the PC is monitoring 2 COM port, or handling and doing traffic to 2 COM port. Each of the Raspberry Pi also monitoring RFcom0 and also its own TTYSO. So monitoring signal between the PC itself, and also it's sending signal to the CM550. In this case, the CM550 doesn't send anything back to the RPi, but that can be done too. And from previous video demonstration, you know that my favorite is remote packets. So we're using a remote packet in here too. So the basic Python code, you see, just using PYSERIAL, open COM4, open COM9, flush all the input and output buffer to make sure everything clean. That's on the PC side. And on each of the RPi side, and just use PYSERIAL again. So you open up serial 0 or TTYSO, that's the same thing. And then also watch out the port RFcom0. I found you can use serial 1 also, it works. Okay, so how do we want to work all together? QUADRUPED, PTC, and the PC together. And I finally figured out a systematic way to get things all work together. So first step is we're concentrating on the QUADRUPED right now. So this is a window, this is a VNC viewer window of the QUADRUPED in desktop, essentially. So first you need to create a terminal, bash terminal, and send the command sudo ifcom watch HCI0. So what it does, it turns the service for the Bluetooth on and keep on watching HCI0 port, which is the same thing as RFcom0 also. There are many pseudonames in the operating system of the RPi. Okay, so that's done. Also, you pull up the code that you want to run on the RPi, which is here. And you can see this is what Visual Studio Code looks like on the RPi. It's the same thing you hear on PC. So get your Visual Studio Code ready, but don't run this code yet. Okay, so that's take care of the QUADRUPED. PTC, same way. Start a terminal, run the IFCOM service, get the VS Code ready, but don't run it. Okay, so when that's done, I'm zooming back out on my PC desktop here. So this one here is the VNC viewer of the QUADRUPED, and this is the VNC view of the PTC over here. Okay, and then over here, this is a Visual Studio Code for the code that run on the PC. You can see that, you know, basic same interface exactly. Okay, now when you start running the code on the PC, more often than not, it runs for about a second or two, and then it will fail. It will drop out. If you have, I'll show you a little bit detail later. Basically, because the very rarely that I can get both of these robots connected together. So like this one, for example, the PTC connected, but the QUADRUPED was not connected properly through Bluetooth. And the way I designed the code on the PC is when it hit that, it just failed over here. It stopped the code. Okay, all right. So when it run PTC connected to PC, if you look at it, it will send that message, press Ctrl+C to hang up. So that's the message you want to see all the time. So okay, so eventually though, both of them will be connected to the PC. At that time, you will see the two images coming up. You see get darkened because they are not. The service is there, but I have not sending, or I'm not ready to send any signal into any robot yet. So they're using a darkened picture. But the menu, the main menu, kind of come up here. You can see. So they're not on yet, shall we say? Okay. Then we shift back into the two RPi and actually start running the code on the QUADRUPED and a PTC. Run them. Okay. So when you run them, you're going to see this. So eventually run, and then you see the output from the Pi camera is connected to both robots. We will start showing something over here. Okay. Then I can go back to the PTC on the PC side and then toggle them on. So you see they have in the brighter images here. And then you can start pushing keyboard and stuff like that on the PC, and then we will send over here to each of them, because I have both of them on, so whatever I push here on the PC will be sent to each of them, and then they come back. I show you more detail in the next slide. Okay, like here. So when it's connected, I send a right arrow over, so actually it's sending a number 8 over to the PTC and the quadruped. That's a message right here. So the quadruped and PC will respond, would say, oh, PC message received. I receive this, and I immediately turn around, send the whole remote packet back to the PC, which is responding by this receive. So right now all it does is that, but later I can more sophisticated information. But I just want to check to see that to verify a bidirectional flow between the PC and each RPi. Interesting enough, here I push up and arrow, and then I push right arrow right away after it. You can see it combined. The up arrow would mean numerical 1. So you can see 8 plus 1 is 9, and it's a 9 over. And each of the pi received 9, and then it's send it back. So at least we can see that the communication scheme is working between the PC and the RPi. The communication scheme between the RPi and CM-550 already worked in previous project demonstration already done, so I'm not repeating it here. Eventually you finish playing and you push escape on the PC side. The PC side pattern card will stop, and you can see it exited out. And then eventually the code on the PTC and the quadruped will run for maybe another second or two, and then they also drop out because they're disconnected from each other. So so when communication disconnected, the RPi code will also stop, and then this is a picture of the terminal. It will be disconnected, and then you just switch to the waiting for someone to connect to it again. So this is the video. So previous with communication scheme, I want to show how it worked between the PC and each robot. Now this is the robot code by itself, okay, trying to run between it and it worked between it and the CM-550 and the robot servo, trying to autonomously track a certain region of interest via the Pi camera here. Okay, so right now it's already got it lined up. It's looking at this ROI and ready to be the color property of this ROI to be extracted, and then it will be used to track it autonomously. So here we go, the video. This is a test code on the PTC running alone. It's ready to extract the ROI. Okay, just extract the data out here. Just extract the ROI, okay. And let's see if it can track on its own. The lighting is not great. That is tracking, so I'm taking that one out of the way. So you see the camera is supposed to give 30 frames per second, but actually processing looks like what, 15 to me? Tracking it. So it's not very smooth, quite smooth yet. And remember, this is Python interpreter mode, and it's 64-bit Raspbian, but still it's faster than 32-bit Raspbian, but it's still slow. See, it kind of almost stopped there. Okay, we're still moving around. You're gonna stop here. Okay, so in the next one, a similar thing, but for the quad. Okay, so still same. This is a ROI here. I'm about to extract it and then tell it to track, but using the quadruped. And remember, the quadruped, when it's moving around, it doesn't care about the data it receives. Only when it stops that it take that data and decide whether to test and learn or not. Okay, and how to track with the target. This is a test of the quadruped by itself. So it's ready to extract the ROI. So we go extract. So the next time pick it up. Let's see if we can track it. Not bad. Better
Okay,
lighting.
it's tracking.
Get rid of lots of junk.
Seem to be fairly stable.
Let's see if it will follow it or not. So I just move the target, so the target over here now. You see it's lagging quite a bit between real physical time and so OpenCV is charging around. Also, it's a project up.
Yep, now lost everything.
It knocked out everything. Okay, so this is all three systems working together now. So this is VNC viewer of the quadruped back there. It's looking at the blue area, and this one here is looking the PTC looking at the red down here. Okay, so both of them are in the midst of the autonomous mode of trying to track the color patch that they are supposed to do. On the PC side, you can see the code, the supervisory code, shall we say, is also running. And I'm ready to send command to both robots over here. So everybody running at the same time. And then, let's see. So they start doing already. And stop a little bit here. You probably notice that the camera is updating or showing its data even more slowly. You see, the image is even more choppy now. Okay, so
here we go.
Everything is being run now, and the system is just too slow. And then we have bad lighting here too.
So I'm gonna go over to the PC right now and send a big command.
So I'm going over here and trying to make this one active. The PC inactive, they're coming up here. It will is active, and then see, it's pretty fast. So anytime that I push anything over here, it's sent to the bot, and then the message come back. So VT communication speed is pretty decent. It was set at 57K, but it looks like it's decent enough. But these guys, OpenCV, just couldn't handle it. The RPi 4B 64-bit is still not enough. You see, the communication between the robots is pretty good because it just sends 6 bytes, simple. But here we have images to be processed, so it's
essentially completely chaos. Too much load for the Pi system.
So the two RPi are just too much, couldn't handle it. So comparison, for example, like in the first two video, the PC and quadruped are by themselves, so they the RPi had to serve as a VNC server to the PC viewer. It's one curve heavy load, I think. Pi camera had to be working, OpenCV working, and then also their serial communication will wire TTYSO 0 to the CM-550. So that's went by themselves. When all three of them work together with the PC, you can see that VNC RPi had to be VNC server, run the Pi camera, OpenCV as before, and then on the communications wire, Bluetooth is added, and that seemed to be draining, requiring lots of resources from RPi. It slowed the OpenCV stuff down quite a bit, you notice, even further. So can do Python with this kind of project. So in my next is I have to work in C++ solution in C, okay, or maybe have to wait until RPi 5 coming out. They always have more powerful, more faster, more memory every time. So right now, this kind of project is just too much for the RPi. Maybe the Jetson Nano can do it. We'll see. And also one last one is about the Microsoft Visual Studio Code. This is the first time I use it on the PC as well on the RPi. And the Visual Studio Code was released for Raspberry Pi in early February, I think, this year. So I saw that, and then I found that Microsoft provides lots of web-based learning resources. I went through that, quite a few hours with that. But if you follow and you try something, it turned out that surprisingly easy to use, at least for Python. I haven't tried to integrate C++ with Visual Studio Code yet, but it was quite easy to use Python on PC and RPi. And the interface is the same, the procedure almost the same to set it up. So until then, later.